Why does gravity, a force that has no surface and no shape of its own, so patiently sculpt planets, moons, and stars into near-perfect spheres, no matter where they form in the universe? If you find quiet comfort in gentle explanations of the cosmos, you are warmly welcome here, and a soft like or a calm subscription helps keep this small corner of science glowing. Gravity begins its work without ceremony, without intention, and without awareness. Yet its effects are among the most recognizable patterns in the universe. Long before a planet has oceans or air or continents, before it has a name or a place in anyone's imagination, it begins as scattered matter, grains of dust, flecks of ice, atoms drifting through space after the birth of a star. These fragments move slowly at first, guided by subtle gravitational pulls, each piece feeling the presence of every other piece, however faintly, across the emptiness. Gravity does not choose a direction. It does not prefer left or right, up or down. It reaches equally in all directions at once, like a quiet invitation extended outward from every particle of mass. As these tiny pieces drift, they begin to gather. A grain of dust pulls on another grain, just enough to nudge it closer. Over time, clusters form, and clusters pull in more material. This process is slow, almost unimaginably slow, unfolding over millions of years. Yet, from this patient accumulation, something remarkable begins to happen. As mass increases, gravity grows stronger, and the growing object starts to feel its own pull more clearly. Every part of it is drawn inward, toward a shared center, a point that is not chosen but simply emerges as the balance of all the pulls combined. At first, these early bodies are irregular, lumpy, and uneven. They look nothing like the smooth planets we know. They are shaped more like rough stones than spheres, their surfaces scarred by collisions, and their interiors loosely held together. But gravity does not stop working once something has formed. It continues, quietly and persistently, pressing inward from every direction. Where there is extra mass sticking out, gravity pulls it back toward the center. Where there is less mass, surrounding material presses in to fill the gap. This inward pull acts like a slow, universal smoothing process. Imagine holding a soft piece of clay in your hands and gently pressing from all sides at once. You are not carving or shaping deliberately. You are simply applying even pressure, allowing the clay to settle into the most balanced shape it can find. Over time, sharp edges soften. Protrusions sink inward. The clay becomes round, not because roundness was a goal, but because it is the natural outcome of equal pressure applied in every direction. In physics, this balance is called hydrostatic equilibrium, a state where the inward pull of gravity is perfectly matched by the outward resistance of the material itself. For planets and stars, that resistance comes from the strength of the material, from pressure, and in stars, from the energy released by nuclear fusion. When an object becomes massive enough, gravity overwhelms the rigidity of rock or ice, and the material begins to flow, not like liquid water, but slowly over geological time. Mountains sink, valleys rise. The entire body relaxes into a shape where every point on the surface is, on average, the same distance from the center. This is why small objects in space, like asteroids, can remain oddly shaped for billions of years. Their gravity is too weak to force their material into a sphere. They keep their jagged forms, their uneven silhouettes, because the inward pull is not strong enough to overcome the stiffness of their structure. But once an object crosses a certain threshold of mass, gravity takes command. From that point on, roundness becomes inevitable. The Earth, when it first formed, was not the gentle blue sphere we recognize today. It was a molten world, its surface a shifting sea of magma. In that state, gravity had an easier time shaping it. Liquid rock flows readily under pressure, allowing the planet to settle into a nearly spherical form. Even now, Earth is not a perfect sphere. It bulges slightly at the equator because of its rotation, flattened just a bit at the poles. This subtle distortion is another reminder that gravity works alongside motion, balancing inward pull with outward forces created by spin. Other planets tell similar stories. Jupiter and Saturn, made mostly of gas, are even more visibly flattened by rotation. Their immense gravity pulls their atmospheres inward, but their rapid spin stretches them outward at the equator. The result is not imperfection, but equilibrium, a shape that reflects all the forces acting at once. Gravity does not insist on perfect geometry. It allows compromise, as long as balance is maintained. Stars, too, are shaped by this same quiet rule. Our Sun is a sphere because gravity pulls its vast mass of hydrogen inward, while the energy released by nuclear fusion pushes outward. The two forces meet in a stable embrace, holding the star in a round form that can persist for billions of years. Even in death, when a star collapses into a white dwarf or a neutron star, gravity continues its sculpting, compressing matter into spheres of extraordinary density. On the largest scales, gravity's tendency toward roundness becomes even more profound. Entire galaxies, though shaped by rotation and collisions, often show a soft symmetry, their stars orbiting a common center, their mass distributed in ways that echo the same principle. Gravity gathers, centers, and balances again and again across scales that range from the pebbles to clusters of galaxies. What is especially calming about this process is its inevitability. No guiding hand is required. No plan is imposed. Gravity simply follows its nature, and from that simplicity, order emerges. Roundness is not a design choice. It is the quiet signature of balance the shaped matter takes when left to settle under its own weight, given enough time and enough mass. There is a gentle lesson hidden here, one that physicists often note with a kind of quiet admiration. The universe does not rush toward complexity. It allows complexity to arise from simple rules applied patiently. Gravity does not hurry. It presses inward at the same rate whether the object is a newborn planet or an ancient star. It does not correct itself or change its mind. It simply continues, allowing time to do the rest. When we look at the moon, its round face hanging calmly in the night sky, we are seeing gravity's long work made visible. The moon is smaller than Earth, yet still massive enough for gravity to have shaped it into a sphere. Its ancient lava plains and cratered highlands are arranged across a curved surface that tells the story of inward pull and slow relaxation. Every circular outline is a memory of forces that have been acting for billions of years. Even our own bodies are shaped in subtle ways by gravity. Though we are held together by chemical bonds and biological structures, gravity still presses us toward the ground, still defines what feels up and down, still influences the way fluids move within us. On Earth, gravity is strong enough to give us a sense of orientation, but not strong enough to force us into spheres. That distinction, too, is a matter of balance. In space stations where gravity's pull is weaker, liquids form floating spheres, surface tension taking over where gravity steps back. Water beads drift, perfectly round, not because gravity demands it, but because without gravity's dominance, other forces express their own preference for balance and minimal energy. Roundness appears again, arising from a different rule, yet echoing the same theme. Nature often favors shapes that minimize tension, that distribute forces evenly, that settle into quiet equilibrium. As scientists like Isaac Newton first described gravity as a universal attraction between masses, and later, as Albert Einstein reframed it as the curvature of spacetime itself, the outcome remained the same. Whether thought of as a force or as geometry, gravity draws matter together, and in doing so, it smooths and centers. In Einstein's view, mass tells spacetime how to curve, and curved spacetime tells matter how to move. When matter follows those curves inward from all directions, round shapes naturally arise. This understanding deepens when we consider time. Gravity does not act instantly to make something round. It requires patience on a cosmic scale. Mountains rise through tectonic forces, then slowly sink under their own weight. Craters form from impacts, then soften over eons. The surface of a planet is a conversation between gravity and time, where sharp features are temporary and smooth curves are enduring. There is something deeply reassuring about this. In a universe that can seem chaotic, filled with explosions, collisions, and violent change, gravity offers a kind of steady background presence. It does not prevent upheaval, but it ensures that, eventually, balance returns. After the chaos of formation, after the heat and impacts, a planet settles. It becomes round, stable, and calm enough for oceans to collect, for atmospheres to form, for life, in rare cases, to emerge. Even black holes, the most extreme objects gravity creates, are defined by simple, elegant shapes. Despite whatever complexity went into their formation, black holes are described by just a few properties: mass, spin, and charge. Their event horizons are smooth and nearly spherical, gravity having erased the messy details of their past. In this way, gravity is not only a sculptor, but also a quiet simplifier, reducing complexity to calm symmetry. As you hold this idea gently, it can feel as though the universe itself prefers rest. Not stillness, but balance. Not uniformity, but harmony among forces. Roundness is one of the visual expressions of that harmony. A shape that whispers of inward pulls perfectly shared, of matter allowed to settle without resistance. The next time you see a planet through a telescope, or a photograph of a distant moon, or even a drop of water catching the light, you are seeing the same principle at work. Forces distributing themselves evenly. Energy finding a minimum. Nature choosing the calmest shape available under the circumstances. Gravity does not announce its presence. It simply continues, quietly shaping the cosmos, one sphere at a time, across the long unhurried stretches of cosmic time, pressing gently inward, allowing everything that can, eventually, to become whole and rounded and at rest within itself. Gravity's quiet preference for roundness also reveals something subtle about how matter responds when it is allowed to move freely. Inside a large planet, rock does not behave the way it does in your hand. Under immense pressure and heat, solid stone can slowly flow, grain by grain, atom by atom, responding to gravity as patiently as thick honey responds to a gentle tilt. This slow movement is almost impossible to notice on human timescales, yet across millions of years it becomes decisive. High regions sink because they carry extra weight. Low regions rise because surrounding material presses inward. The planet adjusts itself not through sudden change, but through an unending sequence of microscopic shifts, each one guided by gravity's steady pull toward the center. This process never truly ends. Even now, Earth continues to reshape itself. Continents drift. Ice sheets grow and melt, subtly redistributing mass. As they do, the planet's crust responds, lifting in some places, settling in others, always seeking balance. Gravity acts as the referee in this slow adjustment, ensuring that no region remains too heavy or too light for long. The roundness we observe is not frozen perfection, but a living equilibrium, maintained through constant, gentle correction. On worlds with less internal heat, like Mars, the story is quieter but still present. Mars is smaller than Earth, and its gravity is weaker, yet strong enough to have shaped it into a sphere long ago. Its towering volcanoes, like Olympus Mons, are reminders that gravity sets limits. On Mars, lower gravity allows mountains to grow taller than they could on Earth, but even there, the planet's overall shape remains round. Gravity tolerates variation on the surface, but it insists on balance in the whole. Farther out, icy moons orbiting the giant planets show the same principle at work under different conditions. Moons like Europa and Enceladus are wrapped in thick shells of ice, beneath which liquid water may flow. Their surfaces are cracked and ridged, yet their global shapes are smooth and spherical. Tidal forces from their parent planets flex them gently, warming their interiors and keeping gravity's sculpting active. Even ice, under the right conditions, yields to gravity's long embrace. There's something quietly poetic in how gravity treats all matter the same. Rock, metal, ice, gas, plasma all respond to the same inward pull. The differences we see arise not from gravity changing its behavior, but from materials resisting in their own ways. When resistance is low or time is abundant, gravity's signature becomes unmistakable. Roundness appears not as a symbol, but as evidence, a record of forces evenly shared. In laboratories on Earth, scientists recreate fragments of this behavior in subtle ways. They study how fluids settle, how droplets form spheres, how powders compact under pressure. These experiments echo what planets do on vast scales. The same equations that describe a droplet of oil rounding itself on a surface can, when extended, describe the equilibrium of a star. Scale changes, complexity grows, but the underlying tendency toward balance remains. Even the mathematics of gravity reflects this simplicity. When physicists solve the equations for a mass attracting itself equally in all directions, the solutions naturally lead to spherical symmetry. It is the most efficient arrangement, the one that requires the least energy to maintain. Nature often favors such arrangements, not because they are beautiful, but because they are stable. Beauty, when it appears, is a byproduct of balance achieved. There is also a quiet humility in recognizing that roundness is not universal. Objects must earn it through mass and time. A pebble drifting through space does not become round simply by existing. It must gather enough material, enough weight, for gravity to overcome rigidity. This threshold marks a transition from object to world, from debris to planet. Astronomers even use this criterion when defining what counts as a planet, whether it has cleared its orbit and achieved hydrostatic equilibrium, whether gravity has shaped it into a sphere. This definition connects shape to identity. A planet is not just something that orbits a star. It is something that has allowed gravity to fully express itself within it. In that sense, roundness becomes a quiet declaration that an object has matured, that it has spent enough time under gravity's influence to settle into its role. As you think about this, it becomes clear that gravity is not an aggressive force. It does not push or shove. It invites matter inward, and matter responds according to its nature. Where it can flow, it flows. Where it resists, gravity waits. Given time, patience always wins. Sharp edges soften, irregularities fade, balance emerges. This patience is written into the night sky. The calm arcs of planetary disks, the steady glow of stars, the gentle curves of moons all speak of processes that unfolded without urgency. They remind us that the universe is not driven by haste, but by consistency. Gravity does not need to act quickly because it never stops acting at all. There is a certain comfort in knowing that the same force shaping distant planets is quietly present here, holding oceans to Earth, keeping the moon in its path, guiding the slow dance of tides. Gravity connects us to the roundness we observe, not as spectators, but as participants. We live on a world that has been patiently shaped into balance, and our own sense of stability rests on that achievement. As time continues, gravity will keep working, long after surfaces change and atmospheres evolve. It will smooth what can be smoothed, center what can be centered, and allow complexity to rest upon a foundation of equilibrium. In this way, roundness is not an end state, but a background condition, a gentle assurance that beneath all variation, a quiet balance endures, holding worlds together as they drift through the vast, unhurried expanse of space. Gravity's influence reaches even into places where matter seems almost weightless, where structures are so diffuse that shape becomes a subtle suggestion rather than a solid outline. Clouds of gas drifting between stars, for instance, begin as sprawling, irregular regions, their atoms spread thin across light years. Yet within these clouds, gravity is quietly at work. Denser pockets pull in more material, becoming denser still, and over time these regions begin to contract. As they do, the same principle asserts itself. Inward pull from all directions encourages symmetry. What begins as a vague concentration slowly tightens, rounds, and condenses, eventually giving birth to a new star. During this collapse, gravity does not rush. It allows heat to build, pressure to rise, and rotation to assert itself. The forming star spins, flattening slightly, while surrounding material settles into a disk. Even here, roundness appears in layers. The star itself becomes a glowing sphere, while the disk around it carries the raw material for future planets. Gravity shapes both, honoring balance while permitting variation. Within that disk, particles collide and stick, repeating the same ancient story on a smaller scale. Pebbles become boulders. Boulders become planetary embryos. Each stage brings increased gravity, and with it, a stronger tendency toward roundness. It is a recursive process, the same rules applied again and again, each time producing familiar shapes from new beginnings. This repetition across scales hints at something deeply consistent about the universe. The same gravity that shapes a droplet of water, given the chance, can shape a planet, a star, or even a cluster of galaxies. The difference lies not in the rule, but in the patience required. Larger systems ask for longer timescales, but gravity is always willing to wait. In galaxy clusters, gravity binds hundreds or thousands of galaxies together, creating vast structures that curve space-time itself. Though these clusters are not solid objects, their mass distributions often show a rough symmetry, a tendency toward smooth, rounded halos of dark matter that envelop the visible galaxies. Even invisible matter, detected only through its gravitational effects, appears to follow the same quiet preference for balance. This tells us something important. Roundness is not about surfaces. It is about distribution. It emerges wherever mass is allowed to arrange itself under its own influence, free from strong external constraints. Gravity does not care what matter is made of, or whether it can be seen. It only responds to mass and energy, shaping them into forms that reflect shared pull and mutual influence. There is a certain gentleness in how gravity resolves conflict. When forces compete, gravity seeks compromise rather than dominance. Rotation stretches objects outward. Internal pressure pushes back against collapse. External tides distort shapes. Gravity listens to all of these influences and finds a form that accommodates them. The result may not be perfectly spherical, but it will be stable, a shape that can endure. This endurance is part of what makes round worlds feel calm when we observe them. They appear settled, finished in a sense, even though change continues beneath their surfaces. Their curves suggest rest, as though the chaos of formation has been absorbed and resolved into something quietly complete. Human minds are sensitive to this. We find circles and spheres reassuring, perhaps because they imply continuity, no beginning or end, no sharp interruption. It is intriguing to realize that this aesthetic response may be rooted in the same physics that shapes planets. Our sense of calm mirrors gravity's preference for equilibrium, yet gravity does not eliminate all irregularity. It allows for texture, for detail, for history to remain written on surfaces. Craters persist. Mountains stand. Rings encircle planets. These features exist within the broader roundness, adding character without breaking balance. Gravity is permissive in this way. It sets the stage, then allows variation to unfold upon it. As time moves forward, gravity's role becomes even more pronounced. When stars exhaust their fuel, gravity takes over, drawing their outer layers inward, sometimes violently, sometimes gently. Red giants shed material into space, forming spherical shells that glow softly before fading. Supernova remnants expand outward, often forming round, ghostly bubbles that mark the boundary between explosion and equilibrium. Even after these dramatic events, gravity remains. It gathers the scattered remnants, seeding future generations of stars and planets. Roundness appears again, not as repetition, but as continuity, the universe remembering its own rules. In this sense, gravity acts like a quiet memory woven into space-time itself. Wherever mass accumulates, the memory awakens, guiding matter toward familiar forms. It does not require awareness. It does not store information in the way minds do. Yet its consistency across billions of years gives the universe a recognizable coherence. When you imagine the cosmos in motion, it is easy to focus on the spectacular moments, the collisions and explosions. But beneath all of that is gravity's steady presence, shaping outcomes long after the brightness fades. It is the reason planets remain planets, stars remain stars, and worlds once formed hold together through deep time. This constancy offers a subtle kind of reassurance. It suggests that while change is inevitable, balance is never far away. Given time, forces distribute themselves. Extremes soften. Systems settle. Gravity does not promise permanence, but it does promise coherence. As you rest with this idea, the roundness of the universe begins to feel less like a coincidence and more like a quiet signature. A gentle mark left wherever matter has been allowed to breathe, to move, and to respond to the same simple pull. Endlessly patient, endlessly even, guiding everything that can, toward a shape that holds together without strain, floating calmly within the vast, unfolding silence of space. Gravity's behavior becomes especially clear when it interacts with other forces, because the outcome can be measured, predicted, and verified. When a planet rotates, for example, material at its equator moves faster than material near its poles. This motion produces a small outward effect that slightly counters gravity. The result is a gentle equatorial bulge. Earth is wider at the equator than from pole to pole by about 43 kilometers, a difference that can be measured precisely. Jupiter shows this effect even more strongly because it spins faster and is made mostly of fluid gas. These shapes are not imperfections. They are exact solutions to competing forces finding balance. Physicists can calculate these shapes using gravity, rotation rate, and internal structure. The predictions are made long before spacecraft arrive. When detailed measurements are taken, they consistently confirm what the equations describe. Gravity pulls inward uniformly. Rotation pushes outward predictably. The final shape reflects both, settling into the most stable configuration possible. The same clarity appears in far more extreme objects. Neutron stars are formed when massive stars collapse, compressing more mass than the Sun into a sphere only about 20 kilometers across. Their gravity is so strong that atomic structures are crushed. Yet even under these conditions, neutron stars are round. Their immense gravity overwhelms all material strength, forcing matter into a smooth, spherical distribution. Their regular shapes allow them to rotate with extraordinary stability, producing pulses of radiation that arrive with clock-like precision. Black holes follow the same rule even more strictly. According to general relativity, any isolated black hole settles into a simple, symmetric form. If it does not rotate, its event horizon is spherical. If it does rotate, it becomes slightly flattened. All complexity from the original star is erased. Gravity removes irregularity and leaves behind balance. Observations made through gravitational waves and horizon-scale imaging are consistent with these predictions. Nothing in this process is symbolic or interpretive. Roundness is not an aesthetic outcome. It is the direct physical result of gravity acting equally in all directions. If gravity were directional or uneven, planets would not become spherical. If matter resisted differently, stars would tear themselves apart. The fact that they do not is one of the strongest confirmations of how gravity works. Across the universe, this same rule applies without exception. Wherever matter gathers and has enough mass to overcome internal rigidity, gravity redistributes it until balance is reached. Time allows this redistribution to complete. The result is a shape that endures because every part supports every other part equally. When a planet becomes round, it is not completing a transformation. It is reaching a condition of stability. Gravity has finished correcting large imbalances and now maintains the shape quietly, continuously. This is why round worlds feel settled when we observe them. They are not static, but they are balanced, held together by a force that does not waver. In this way, gravity makes everything round not by intention, but by consistency. It pulls the same way everywhere, every moment. Given enough mass and enough time, matter has only one way to respond. It moves inward, redistributes evenly, and settles into a form that can last, floating calmly through space, shaped by nothing more than gravity doing exactly what it always does. Gravity's work does not stop once a world has reached a stable, rounded form. From that moment onward, gravity becomes a quiet custodian, maintaining balance as conditions change. Impacts strike the surface, climates shift, interiors cool or warm, yet the overall shape endures. This persistence comes from the way gravity distributes stress. When mass is added to one region, perhaps by a large volcanic plateau or a thick ice sheet, gravity responds by gently pulling that excess downward. The underlying material flows slowly away from the load, restoring balance. This process, known in geology as isostatic adjustment, is another clear demonstration of gravity enforcing equilibrium over time. On Earth, this adjustment can be measured today. Regions once buried under massive ice sheets during the last ice age are still slowly rising as the crust rebounds from the removed weight. The land lifts by millimeters each year, not because anything is pushing it up, but because gravity is allowing the planet to return to a balanced distribution of mass. The roundness of the planet is not threatened by these changes. Instead, it is quietly preserved. The same principle applies beneath the surface. Deep inside planets, pressure increases steadily toward the center. This pressure comes directly from gravity acting on the layers above. Each layer supports the weight of everything above it, creating a smooth gradient of compression. This gradient is symmetrical, centered, and predictable. It is why planetary interiors arrange themselves into layers, heavier materials sinking toward the center, lighter materials rising above. Gravity sorts matter efficiently, not by choice, but by necessity. This internal sorting further reinforces roundness. When dense material collects at the center, gravity becomes even more evenly distributed. The planet's center of mass stabilizes. Deviations are corrected more effectively. Over time, the interior structure and the exterior shape align, both reflecting the same inward pull. In gas giants, this process is even more fluid. Hydrogen and helium move freely under gravity's influence, forming smooth, continuous layers without sharp boundaries. Storms rage in their atmospheres, bands shift and swirl, yet the planet as a whole remains calm and rounded. Gravity holds the chaos in place, preventing it from disrupting the global shape. The storms are surface expressions of energy, not threats to equilibrium. Even rings and moons participate in this balance. Rings form where gravity allows material to spread without clumping into a sphere, usually because tidal forces from a nearby planet prevent full collapse. Moons, farther away, are free to gather themselves. Once they reach sufficient mass, gravity completes the familiar work. The system organizes itself naturally, each component finding the form permitted by gravity and motion together. This clarity extends to how scientists think about shape itself. In physics, a sphere is not treated as a special or ideal form. It is treated as the expected outcome when conditions are symmetric. If forces act the same in every direction, symmetry follows. When that symmetry is broken by rotation, tides, or external pulls, the shape adjusts accordingly. There is no ambiguity in this reasoning. It follows directly from the laws that govern motion and force. Because of this, roundness becomes a diagnostic tool. When astronomers observe an object's shape, they can infer its internal state. A round body suggests sufficient mass and internal mobility. An irregular body suggests rigidity or insufficient gravity. Shape becomes evidence, not decoration. It tells a story about history, composition, and forces at work. Over billions of years, gravity has applied this logic consistently. Young planetary systems look messy, filled with debris and irregular bodies. Mature systems show order, with spherical planets tracing stable orbits. This progression is not guided. It emerges naturally as gravity reshapes what time allows it to reshape. There is also an upper limit to this process. When gravity becomes too strong, roundness gives way to collapse. Stars burn steadily while pressure balances gravity. When fuel runs out, gravity wins. The star contracts, sometimes violently. Yet, even in collapse, symmetry remains. The implosion proceeds inward from all directions. The end state, whether a white dwarf, neutron star, or black hole, is still round, because gravity still acts uniformly. In this way, gravity defines both stability and change. It allows systems to rest, and it drives them to transform. But at every stage, it enforces coherence. Matter does not scatter randomly. It organizes around a center. The result is a universe filled with curved horizons, rounded worlds, and smooth transitions between extremes. This consistency is one of the reasons physics is possible at all. If gravity behaved unpredictably, shapes would vary wildly without pattern. Instead, the same forms appear again and again, allowing scientists to test ideas, refine models, and trust that what applies here applies elsewhere. A planet around another star follows the same rules as Earth. A star in a distant galaxy holds itself together the same way the Sun does. As this understanding settles in, roundness becomes less of a visual curiosity and more of a physical statement. It says that forces are balanced. It says that time has been sufficient. It says that matter has responded fully to gravity's presence. Nothing more is implied, and nothing less is required. Gravity does not smooth everything instantly. It waits. It allows complexity to exist on the surface while maintaining simplicity underneath. That balance between detail and order is what gives the universe its texture. Worlds can be rugged and scarred, yet still whole. Stars can be turbulent, yet still stable. Systems can evolve, yet remain coherent. And so gravity continues, moment by moment, doing the same quiet work everywhere. Pulling inward, distributing mass, correcting imbalance, allowing roundness to emerge wherever conditions permit. Not as a mystery, not as a metaphor, but as a direct and unavoidable result of how mass and space interact, endlessly shaping the universe into forms that last. Gravity also defines where roundness stops being optional and becomes unavoidable. This boundary is not arbitrary. It can be calculated from material strength and mass. Rock can support only so much unevenness before it fails under its own weight. Ice supports even less. This is why icy bodies become spherical at smaller sizes than rocky ones. Once gravity produces pressures greater than what the material can hold rigidly, deformation begins. From that point on, gravity no longer negotiates with structure. It reshapes it. This threshold marks a profound shift in behavior. Below it, objects behave like assembled pieces. Above it, they behave like worlds. The difference is not philosophical, it is mechanical. Below the threshold, stresses remain localized. Above it, stresses propagate through the entire body, allowing mass to redistribute globally. Roundness emerges because gravity is now acting on the whole object as a single system rather than on disconnected parts. This system-level behavior explains why planets can heal. Large impacts leave scars, but over time those scars soften. Crater rims slump, basins fill, the surface relaxes. Gravity does not erase history instantly, but it steadily reduces extremes. What remains visible after billions of years is not disorder, but moderation. On bodies with active interiors, this process accelerates. Heat lowers material strength, making gravity more effective. This is why early planets, hot from formation and radioactive decay, round themselves more easily. As they cool, their shapes become locked in, preserved by increasing rigidity. Yet even then, gravity never stops acting. It simply works more slowly, limited by what matter will allow. In stars, gravity operates without such resistance. Plasma offers little structural support. As a result, stellar shapes are determined almost entirely by gravity and rotation. This simplicity allows stars to be modeled with remarkable precision. Their internal pressures, temperatures, and densities follow smooth curves inward, all dictated by gravity's pull. These profiles are not guessed. They are derived and confirmed through observation. The same clarity appears when stars form binary systems. Two stars orbiting each other distort one another slightly through tidal gravity. Their shapes elongate along the line connecting them, yet the distortion remains smooth and predictable. When the stars are close enough, mass can flow from one to the other, guided by gravity through curved pathways. Even in this complexity, symmetry and balance remain central. Gravity's role as a shaper is inseparable from its role as a stabilizer. A rounded shape minimizes variations in gravitational potential across the surface. This reduces internal stress and prevents runaway deformation. In practical terms, roundness is the shape that costs the least energy to maintain. Once achieved, it resists change unless new forces intervene. This energy principle is fundamental. Physical systems tend toward configurations that minimize energy while satisfying constraints. Gravity provides the constraint. Mass must attract mass. The sphere is the configuration that satisfies this requirement most efficiently when conditions are uniform. No other shape distributes gravitational pull as evenly. This is why, across the universe, roundness is common but not universal. It appears where gravity dominates and fades where it does not. It is absent in places where other forces overpower gravity, such as in small objects or rigid structures. The presence or absence of roundness tells us immediately which forces are in control. From this perspective, gravity is not a creative force inventing shapes. It is a sorting force, allowing only certain shapes to persist. Irregularity is temporary unless supported by strength or motion. Balance is permanent as long as gravity remains the primary influence. This understanding removes any sense of mystery while preserving quiet wonder. The universe does not hide its rules. It repeats them patiently, allowing us to recognize them wherever we look. Each rounded world is a demonstration, not a symbol, of gravity operating exactly as described. As time extends forward, gravity will continue to do this work long after stars fade and planets cool. Matter will gather where it can. It will spread where it must. Wherever it gathers enough to matter to itself, it will pull inward, distribute evenly, and settle into a form that can endure. Roundness, then, is not a goal reached once and forgotten. It is a condition maintained, a balance upheld moment by moment. Every second, gravity pulls inward on every part of a planet. Every second, the planet resists just enough to remain stable. This quiet exchange never ends. Seen this way, gravity is not dramatic. It is reliable. It does not announce change. It allows change to finish. It shapes the universe not through forceful intervention, but through consistency applied without pause. And in that consistency, matter finds its calmest arrangement again and again, forming worlds that curve gently around a center, held together by nothing more than gravity being exactly what it is. As worlds grow and mature, another quiet pattern appears alongside roundness, one that keeps the narrative fresh without changing the underlying physics. Shape is not enforced by repetition of force alone, but by the way matter seeks the simplest arrangement it can sustain. Once material begins responding as a whole rather than as separate pieces, it naturally organizes around a center. From that point on, the details become secondary. The overall form stabilizes first, and the finer features are allowed to evolve slowly on top of it. This is why a planet can host towering mountains and deep basins without losing its overall curvature. Those features are local expressions of energy and history, not challenges to the global balance. The planet behaves like a single object with a defined center, and everything else adjusts relative to that. The curve beneath the surface is the dominant structure. What rests upon it is decoration by comparison. Another way to see this is through how pressure behaves inside large bodies. Pressure does not move sideways on its own. It moves inward, layer by layer, responding to the weight above it. This creates smooth internal gradients that are naturally symmetrical. Once these gradients form, they reinforce the outer shape. Any large deviation would require redistributing enormous amounts of material, something nature avoids unless forced. This preference for simplicity also explains why mature planets rarely look dramatically distorted unless something unusual is happening. Strong tidal forces, rapid rotation, or close encounters can stretch a body temporarily. But once those influences weaken, the object relaxes back toward equilibrium. The relaxation may take millions of years, but it happens reliably. Balance is the default state. In systems with multiple bodies, this tendency leads to clear roles. Central objects dominate. Smaller ones adjust. Moons settle into rounded forms if they can, then orbit steadily. Debris that cannot gather enough mass remains irregular, scattered, or flattened into rings. Each structure reflects how fully it has been allowed to respond to inward pull. What keeps this process from feeling repetitive is that it never unfolds the same way twice. Composition matters. Temperature matters. History matters. A rocky world responds differently than an icy one. A fast spinner differs from a slow one. Yet, despite these differences, the destination remains familiar. The details vary. The outcome is recognizable. This universality is one of the strongest indicators that the explanation is sound. When a rule applies across conditions, scales, and materials, it gains credibility. The rounding of worlds is not a special case. It is one expression of a broader principle about how matter behaves when left to itself under attraction. Even in regions where material is sparse, this organizing tendency leaves its mark. Large clouds do not remain filamentary forever unless something interferes. Over time, concentrations become smoother. Edges blur. Centers form. The same logic applies whether the medium is solid rock or diffuse gas. Distribution replaces irregularity when enough time passes. This gradual smoothing also helps explain why the universe looks calmer at large scales than it does up close. Zoom in and you see chaos. Zoom out and patterns emerge. Curves replace jaggedness. Symmetry replaces noise. This is not an illusion. It is the natural outcome of averaging forces across vast distances and times. From this perspective, roundness is less about shape and more about resolution. It is what remains once the universe has had time to resolve competing influences. Sharp features require constant support. Smooth ones do not. Over long durations, unsupported complexity fades. That is why ancient objects often appear simpler than young ones. Youth is irregular. Maturity is smooth. This applies to landscapes, planets, stars, and even larger structures. Time allows systems to settle into forms that demand the least ongoing adjustment. Nothing about this requires intention or design. It requires only consistency. Matter responds the same way today as it did billions of years ago. The rules do not drift. Because of that, outcomes repeat, not mechanically but reliably. When scientists encounter a new object in space and see that it is round, they immediately know several things without further information. They know it has sufficient mass. They know it has existed long enough to adjust itself. They know internal stresses have been redistributed. Shape becomes a summary of history written in curvature. This makes roundness informative rather than decorative. It is a signal, not a coincidence. It tells us that the object is governed by large-scale balance rather than local rigidity. It tells us that inward pull has had time to finish its work. As these ideas settle together, the universe begins to feel less cluttered and more coherent. Different objects, different scales, one underlying behavior. Matter organizes itself when allowed. Extremes soften, centers form, stability follows. And so the cosmos ends up filled with curved horizons and rounded silhouettes, not because that shape was chosen, but because it is what remains after everything unnecessary has been removed. Given enough time, matter always finds its way toward arrangements that can last, quietly shaped by forces acting evenly, patiently, and without interruption. As this pattern continues, it becomes clear that shape is not imposed from the outside, but negotiated from within. Large bodies do not need guidance to organize themselves. They respond to internal conditions, distributing mass until stress becomes uniform. Once that happens, there is no incentive for further large-scale change. The form holds not because it is locked in place, but because it no longer contains strong imbalances that demand correction. This is why worlds that have settled into rounded forms can persist for billions of years with only modest alteration. Their interiors support their surfaces evenly. No region carries a disproportionate burden. Energy can move through them without tearing them apart. The shape itself becomes part of the stability. This internal calm allows other processes to unfold without threatening the whole. Atmospheres circulate. Oceans move. Plates drift. None of these processes are strong enough to disrupt the underlying balance because they operate within it. The curve of the planet acts like a framework, quietly absorbing and redistributing stress. On smaller bodies, this framework never fully forms. Stress remains localized. One impact can permanently distort the shape. One uneven accumulation can tilt the balance. Without sufficient inward pull to unify the structure, the object remains a collection of parts rather than a coherent whole. Its outline records accidents rather than equilibrium. As bodies grow larger, this distinction becomes unmistakable. Their response to disturbance changes. Instead of breaking or remaining warped, they adjust. Material flows, pressure redistributes, and the system settles again. The response is slow, but it is reliable. Over time, adjustment always favors smoothness. This smoothing is not limited to solids. Fluids reveal the principle most clearly. When left undisturbed, a fluid naturally arranges itself so that its surface lies at equal potential everywhere. The result is a curved surface centered around the source of attraction. This behavior can be demonstrated on a tabletop or observed in orbit. The scale changes, the outcome does not. What makes planetary bodies interesting is that they behave like fluids given enough time. Rock that seems immovable becomes pliable when pressure is high and duration is long. This is not metaphorical. It is measured. Laboratory experiments and seismic studies confirm that planetary interiors flow slowly, responding to long-term stress rather than short-term force. Because of this, shape becomes a time-dependent property. Early on, forms are irregular. Later, they relax. The longer a body exists under consistent inward pull, the more complete the adjustment becomes. Age leaves its mark not only on surfaces, but on outlines. This is why some distant moons appear nearly perfect spheres, despite being cold and inactive. Their rounding happened early, when heat made adjustment easier. Once cooled, the shape remained. The roundness is a fossil, a preserved record of conditions long past. The same idea applies to stars at different stages of life. Young stars are turbulent, but their outlines remain smooth. Older stars expand and contract, yet maintain symmetry. Even when shedding material, the ejected shells often expand evenly, forming luminous bubbles that fade into space. The internal balance governs the external result. At the largest scales, clusters of matter exhibit similar tendencies. While individual components move freely, the overall distribution settles into smooth profiles. Sharp edges blur. Density decreases gradually with distance from the center. This is not because motion stops, but because motion averages out. This averaging is a powerful concept. When many interactions occur over long durations, extremes cancel. What remains is the most stable arrangement permitted by the rules. The universe appears orderly not because it suppresses motion, but because it integrates it. This understanding keeps the explanation grounded. Nothing here depends on chance alignment or special conditions. Given mass, time, and attraction, the outcome follows. Remove one of these elements, and the pattern breaks. Include them, and it reappears. Because of this reliability, shape becomes predictive. From mass and composition alone, scientists can anticipate whether an object will be round, flattened, or irregular. These predictions are tested repeatedly and found accurate. The correspondence between theory and observation is direct. That correspondence is what gives confidence in the explanation. It is not inferred loosely. It is confirmed across environments that differ wildly in temperature, scale, and composition. The same behavior emerges because the same constraints apply. As these ideas settle together, the universe begins to feel less crowded with exceptions and more governed by continuity. Differences matter, but they do not overthrow the pattern. They refine it. Roundness, then, is not monotony. It is resolution. It is what remains after competing influences have had time to work through one another. It is the shape of balance achieved, not enforced. Every curved horizon, every smooth limb of a distant world is a quiet record of this process having completed itself. Matter gathered, forces acted, time passed. The system found a way to hold together without strain. And in that sense, the rounded forms scattered throughout space are not repetitive echoes, but confirmations. Each one independently demonstrates the same truth. When matter is allowed to respond fully to attraction and time is allowed to do its work, the result is coherence. A shape that endures because it no longer needs to change. As this settling continues, an important distinction becomes clearer between shape that is maintained actively and shape that is maintained passively. Small structures must constantly resist deformation. A cliff stands only because the rock beneath it is strong enough to hold. A bridge remains intact only because its materials counter stress at every moment. Large celestial bodies do not work this way. Once their mass has organized itself, the form sustains itself naturally. No constant resistance is required. Balance maintains balance. This passive stability is one of the quiet signatures of a mature world. Forces are distributed so evenly that no single region is under exceptional strain. Change can still occur, but it happens within limits. Energy moves through the system without concentrating dangerously. This is why large bodies rarely fail catastrophically unless something external intervenes. Their structure is not fragile. It is self-supporting. This quality also explains why rounded worlds are such effective hosts for long-term processes. Atmospheres can persist. Oceans can remain contained. Internal heat can escape gradually rather than violently. The overall geometry supports continuity. It allows evolution rather than constant disruption. From a physical standpoint, this happens because stresses cancel when they are evenly distributed. Any point on the surface experiences similar conditions to any other point at the same depth. There are no privileged directions, no edges where tension accumulates. The absence of corners is not cosmetic, it is structural. Corners in physics are places where forces concentrate. Sharp transitions amplify stress. Smooth curves disperse it. A sphere minimizes these concentrations better than any other three-dimensional form. That is why pressure vessels, bubbles, and large bodies all converge on similar shapes when allowed. The geometry itself reduces the likelihood of failure. This principle extends even into how energy travels through a body. Vibrations, waves, and heat flow more evenly in symmetrical forms. There are fewer pathways for resonance to build destructively. This contributes to long-term durability. The shape is not just a result of balance, it actively supports it. When scientists simulate planetary formation, this behavior emerges without being programmed explicitly. The models include attraction, motion, material properties, and time. The outcome follows. Irregular forms appear early, then soften. Centralization occurs. Smooth outlines develop. The shape is not specified in advance. It is discovered through the interaction of simple rules. This is an important point. The explanation does not rely on hindsight. It is predictive. When new objects are found, their outlines confirm expectations based on mass and composition alone. When discrepancies appear, they point not to failure of the model, but to additional influences that can then be identified and measured. This is how understanding deepens. Shape becomes a clue. It invites questions that have clear answers. Is the object rotating rapidly? Is it being stretched by a nearby companion? Is its interior still warm enough to flow? Each question leads to measurable consequences. None require speculation beyond established physics. What keeps this subject engaging is that the same rule expresses itself differently in every context. No two planets are identical. No two stars share the same internal story. Yet their forms reveal that beneath those differences, a shared logic applies. The diversity lies in detail. The coherence lies in structure. Even worlds that appear almost perfectly smooth are not featureless. Their history is written in subtle deviations, slight flattening, gentle bulges, minor asymmetries. These are not flaws. They are records. They tell us how fast the body spins, how it cooled, what it interacted with. Shape becomes a physical archive. over very long durations, even these records fade. As energy dissipates and motion slows, outlines become simpler. This is not decay. It is resolution. Systems approach their most economical arrangement and remain there unless disturbed. This long view helps explain why the universe looks the way it does today. Early epochs were chaotic. Matter moved violently. Structures collided. Over time, the most stable configurations persisted. Others did not. What we see now is the result of endurance. Endurance in physics is not about strength alone. It is about balance. Forms that distribute forces evenly last longer. Forms that concentrate stress fail sooner. This principle applies universally, from microscopic structures to the largest bound systems. When this idea settles in, roundness stops being repetitive and starts being informative. Each curved outline is a statement that the system has resolved its internal tensions. Each smooth limb is evidence that time has been sufficient. Each stable form reflects forces that no longer need to compete. The universe does not reward novelty for its own sake. It rewards configurations that can persist. Over vast stretches of time, those configurations become common, not because they are favored, but because they survive. Seen this way, the prevalence of rounded worlds is not monotony. It is testimony. It tells us that matter, given consistency and time, converges on forms that do not ask to be maintained. They simply are. And so, across distances too large to imagine, bodies continue to hold themselves together quietly. Not rigidly, not tensely, but calmly. Their outlines curve gently because nothing inside them is demanding to be otherwise. They have found a way to exist that costs the least effort, a form that remains stable while everything else continues to move, change, and unfold around it. As this picture is rebuilt from a different angle, shape begins to look less like an outcome and more like a record of negotiation. Every large body carries the memory of how it handled stress, motion, and time. That memory is written not in words, but in curvature. The outline tells you whether forces argued or cooperated, whether resistance dominated early or softened quickly enough to allow adjustment. Short-lived disturbances leave marks, but they rarely define the whole. A violent collision may carve a basin, tilt an axis, or scatter debris. Yet the broader form absorbs the event rather than yielding to it. Redistribution follows. Excess weight migrates. Pressure evens out. The system does not erase what happened, but it refuses to let one moment dictate its long-term structure. This refusal is rooted in scale. Large systems respond to averages, not impulses. A single blow matters less than the accumulated influence of everything acting together over immense spans of time. What shapes the whole is not intensity, but persistence. Forces that act continuously, even gently, leave the deepest imprint. Because of this, outlines tend to mature while surfaces remain expressive. Landscapes stay rugged. Atmospheres stay active. Interiors circulate heat. Yet the global form holds steady, as if insulated from drama. The calm curve beneath everything else becomes the reference frame within which all change occurs. This separation between global form and local activity is one of the clearest signatures of a settled body. It tells us that internal freedom exists, but within limits. Motion is allowed, but only in ways that do not concentrate stress. Energy flows, but it disperses rather than accumulates. The geometry itself supports this moderation. Material properties play a decisive role here. When matter can slowly rearrange, it participates in maintaining balance. When it cannot, imbalance lingers. Early conditions often determine which path is taken. Warmth lowers resistance. Time allows rearrangement. Once those opportunities pass, the form becomes more fixed, not because forces stop acting, but because response becomes sluggish. Yet even sluggish response is still response. Deep interiors remain under enormous pressure. Given enough duration, even the most rigid substances yield slightly. The pace is glacial, but it is not zero. Adjustment continues quietly, keeping large deviations in check. This ongoing correction explains why extreme shapes are rare among massive bodies unless something actively sustains them. Distortion requires maintenance. Remove the cause and relaxation begins. The process may be slow, but direction is clear. Balance reasserts itself because it is the lowest effort condition available. What keeps this story engaging is that no two cases resolve in exactly the same way. Composition alters the timeline. Rotation modifies the outline. Neighbors introduce subtle asymmetries. The rule is consistent, but its expression is varied. Familiarity does not erase interest because each instance reveals different constraints at work. Scientists rely on this consistency precisely because it tolerates variation. Shape becomes a diagnostic rather than a curiosity. From it, one can infer internal state, thermal history, and interaction with surroundings. The curve contains compressed information, readable to anyone who knows what to look for. This readability gives the universe a sense of coherence. Objects separated by unimaginable distances still speak the same physical language. Their outlines differ, but their logic matches. Understanding one grants insight into many. Over long durations, the cosmos filters its own complexity. Configurations that demand constant correction fade away. Those that distribute stress efficiently remain. This is not selection in a biological sense, but persistence in a physical one. Endurance favors certain arrangements, and those arrangements become common. The result is not uniformity, but clarity. Variety exists within boundaries set by what can last. Rounded forms appear often because they resolve internal tension effectively, not because alternatives were forbidden, but because alternatives asked too much. Seen this way, curvature becomes a quiet indicator of resolution. It tells us that forces have finished arguing and settled into cooperation. Motion continues, change continues, but the overall structure no longer strains against itself. That calm does not signal an end. It signals readiness. A body that has found a stable outline can host long histories without unraveling. It can accumulate detail without losing coherence. It can change internally while remaining whole. The universe is filled with such bodies, not as repetition, but as confirmation. Wherever matter has been given the chance to reorganize itself fully, it arrives at forms that carry their own stability. Curved, balanced, and unassuming, they persist not because they are perfect, but because they no longer need to fight their own structure to exist. Another layer of interest emerges when shape is viewed as a boundary between freedom and constraint. Inside a large body, matter is free to move slowly, to circulate, to exchange energy. At the boundary, however, that freedom resolves into a clean outline. The surface becomes the place where countless internal motions agree on a single geometry. That agreement is not enforced from above. It arises because every internal path ultimately leads back toward a shared center. This gives outlines a quiet authority. They are not arbitrary skins. They are the visible result of everything beneath them having found a way to coexist. When the interior is unsettled, the surface reflects it. When the interior calms, the surface smooths. Shape, in this sense, is an honest expression of internal state. This honesty is why distortions are so informative. When a body is stretched, bulged, or elongated, the cause can almost always be identified. Rapid rotation leaves a signature. A nearby companion leaves another. The geometry records the influence without exaggeration. Remove the influence, and the record slowly fades. There is also a subtle hierarchy at work. Small features must conform to larger ones. Mountains follow curvature. Atmospheres wrap around it. Oceans fill depressions defined by it. The global outline sets the stage for everything else. It provides a reference that local processes cannot ignore. This hierarchy explains why large-scale balance feels calm, even when small-scale activity is intense. Storms can rage across a planet without threatening its cohesion. Internal convection can churn without distorting the whole. The deeper structure absorbs variation and keeps it from escalating. In this way, shape acts like a moderator. It does not prevent motion. It contains it. It allows complexity to exist without letting complexity dominate. That containment is what makes long histories possible. Time reinforces this moderation. The longer a body exists, the more thoroughly transient extremes are averaged out. What remains is what could not be removed without altering the entire system. The outline becomes the most conservative feature, the last to change. This is why ancient objects often feel composed when observed. They have survived countless disturbances, yet their forms suggest a composure rather than fragility. The curve has endured while details have come and gone. At different scales, the same idea repeats in new ways. Large clouds condense toward smoother profiles. Stellar remnants settle into compact forms. Even collections of objects exhibit softened boundaries over time. The principle does not announce itself. It reveals itself through persistence. What keeps this from feeling repetitive is the diversity of pathways leading to the same kind of resolution. Some bodies round themselves quickly in early heat. Others take longer, adjusting gradually. Some are shaped gently. Others are forced into equilibrium after turmoil. The destination may resemble itself, but the journeys differ. Those journeys leave traces, slight asymmetries, subtle bulges, gentle flattening. These are not flaws. They are signatures of history layered onto balance. They keep each form distinct even within a familiar pattern. This distinction matters. It reminds us that stability does not erase individuality. It preserves it within bounds. Two worlds can share a similar outline and yet be entirely different places. The curve unites them structurally, not narratively. From a physical standpoint, this makes sense. The rules that govern large-scale balance are few. The processes that fill in detail are many. Simplicity at one level allows complexity at another. Without the former, the latter would not last. This interplay is one of the quiet strengths of the universe. It does not maximize variety everywhere at once. It distributes it. Structure where endurance is needed. Freedom where expression is possible. Seen through this lens, rounded forms are not monotonous. They are permissive. They make room for everything else to happen without collapse. They are the background condition that allows richness to unfold. This perspective also reframes how we think about change. Change does not always mean transformation of form. Often, it means movement within form. The outline stays. The interior evolves. This separation allows systems to remain recognizable even as they develop. Over immense durations, this becomes the dominant pattern. Systems that can separate form from detail last longer. Those that cannot dissolve or fragment. The cosmos gradually fills with arrangements that support this separation. None of this requires intention or foresight. It emerges because certain configurations do not demand constant correction. They persist because they are efficient in the most literal sense. They minimize internal conflict. As these ideas settle together, shape becomes less about appearance and more about permission. A stable outline permits time to act without destroying the whole. It permits history to accumulate. It permits complexity to breathe. That is why curved forms are so common among enduring objects. They are not the only possibilities, but they are the ones that allow the longest stories to be told. Weight does not need to announce itself to be effective. Once enough material gathers, influence spreads quietly through every layer, pressing without direction, asking nothing but cooperation. Over long spans, that pressure finds every excess and every shortage, nudging matter away from extremes until nothing stands too far apart from the rest. Protrusions lose their advantage first. They carry more load, feel more strain, and gradually surrender material back toward regions that need it. Depressions respond in the opposite way, accepting what arrives until differences soften. The process is not dramatic. No sudden collapse. No visible motion. Just an unending tendency toward evenness, like a room slowly filling with air until every corner feels the same. Inside large bodies, this redistribution creates a quiet interior logic. Dense components migrate inward. Lighter ones settle above, not as layers stacked deliberately, but as a consequence of pressure seeking the simplest arrangement. Once established, this internal ordering reinforces the outer form. The center becomes an anchor, not a point of tension, but a place where influences cancel cleanly. What emerges from this is not rigidity, but composure. The object holds together because nothing inside it is insisting on escape. Forces circulate rather than accumulate. Energy moves outward gently instead of tearing pathways open. The overall silhouette becomes less a boundary and more a summary of everything happening beneath it. Over time, this composure proves resilient. External events can disturb surfaces, alter rotation slightly, or rearrange shallow layers, yet the deeper arrangement absorbs the change. Adjustment follows without urgency. The form does not need to defend itself. It simply redistributes until the disturbance loses leverage. This behavior explains why certain outlines feel inevitable once a body crosses a particular scale. The material no longer behaves like a collection of parts. It behaves like a single presence. Stress in one region is shared everywhere. The response is collective, not local. Even when conditions are complex, the result remains legible. Rapid spin stretches the body gently. Nearby companions tug and distort it subtly. These influences leave marks that can be read precisely. Nothing is exaggerated. The geometry responds in proportion, revealing cause through form. Because of this proportionality, shape becomes one of the clearest physical records available. It condenses vast histories into a single, readable feature. Long after heat has faded and motion has slowed, the outline continues to testify to what the body has endured and resolved. Variation remains, of course. Some worlds appear almost flawless. Others carry visible asymmetries. These differences do not contradict the pattern. They enrich it. They show how the same principles adapt to different circumstances without breaking. The language of curves, bulges, and flattening is universal because the rules behind it are few. Attraction, resistance, motion, and time interact in consistent ways. Once those interactions are allowed to run their course, certain results become common. This commonality does not make the universe dull, it makes it intelligible. Familiar forms act as anchors, allowing attention to rest rather than scramble. Against those anchors, detail becomes meaningful instead of overwhelming. In that sense, rounded worlds are not repetitive motifs. They are stable canvases. They allow atmospheres to circulate, surfaces to evolve, and histories to unfold without unraveling the whole. They're calm. Outlines do not suppress activity. They enable it. As ages pass, what survives is not what formed most violently, but what settled most thoroughly. Jaggedness requires maintenance. Smoothness does not. Given enough duration, systems drift toward arrangements that ask less of themselves. This drift is not a march toward uniformity. It is a quiet selection for coherence. Bodies that can distribute strain evenly persist. Those that cannot fragment, scatter, or remain small. Seen through this lens, the prevalence of curved silhouettes across space becomes an observation rather than a mystery. Matter responds to influence, spreads stress, and settles when allowed. Over long stretches, the results speak for themselves. Each stable outline marks a point where negotiation ended. Forces no longer compete loudly. They coexist. Motion continues inside. Change continues on the surface, but the overall form remains untroubled. That untroubled state is not an endpoint. It is a condition that allows time to keep moving without erasing what has already formed. Within it, complexity can deepen, history can accumulate, and variation can flourish, all supported by a form that no longer needs to argue with itself. Stillness at large scales does not mean inactivity. Within settled forms, motion becomes organized rather than chaotic. Heat migrates outward. Material circulates slowly. Subtle shifts continue long after dramatic events have faded. What changes is not the presence of movement, but the way movement expresses itself. Instead of pulling the whole apart, it traces loops, cycles, and flows that remain contained. This containment allows internal differences to coexist without conflict. Hotter regions transfer energy toward cooler ones. Denser regions press gently against lighter surroundings. Nothing needs to rush. The system has learned how to distribute imbalance before it grows disruptive. That learning is encoded in the overall arrangement of mass. Over extended durations, this internal cooperation leaves a distinct signature. Large bodies begin to behave less like collections of materials and more like unified entities. A disturbance in one area is felt everywhere, not as shock, but as gradual adjustment. The response is slow enough to prevent fracture, steady enough to prevent drift. Because of this, the most enduring structures are rarely the most rigid. Flexibility, spread across enormous scales of time, proves more reliable than stiffness. The ability to yield slightly, everywhere at once, keeps stress from accumulating. What looks solid is, in fact, quietly accommodating. This accommodation explains why extreme asymmetries are uncommon among massive objects. Sharp deviations demand sustained imbalance. Without constant reinforcement, they fade. The body redistributes what it can until the deviation no longer stands out. Over time, what remains is what required the least effort to maintain. In this way, outlines become conservative features. They change only when the entire system participates. Local rearrangements leave them largely untouched. This makes them trustworthy indicators of long-term conditions rather than short-term events. The same principle can be seen when material spreads outward instead of inward. Expanding shells from stellar remnants, for example, often form nearly uniform envelopes. As energy dissipates, expansion becomes smoother. Differences in speed even out. The boundary settles into a clean front before dissolving entirely. The same logic appears again, expressed through motion rather than containment. Across environments, one pattern repeats quietly. When many influences act together over long periods, extremes lose definition. Variations blend. What survives is what fits comfortably with everything else acting at the same time. This blending does not erase identity, it reframes it. Distinctiveness moves from outline to interior detail. Worlds remain unique not because their shapes differ wildly, but because what happens within those shapes diverges in countless ways. The outer calm creates space for inner variety. Without a stable framework, complexity would be short-lived. With one, it can accumulate patiently. History becomes layered rather than erased. This layering is why long-lived systems feel rich rather than static. They have room to change without needing to reinvent themselves. Their fundamental arrangement remains dependable while everything else evolves. From a physical perspective, this is efficient. Systems that do not need constant correction conserve energy. They persist with minimal expenditure. Over immense spans, such efficiency becomes decisive. Forms that waste energy correcting imbalance give way to forms that do not require correction at all. The universe does not reward effort. It rewards arrangements that ask for little. Over time, those arrangements become common not because they are preferred, but because they last. Seen through that lens, the prevalence of curved, settled forms is simply the residue of endurance. What could not hold together is gone. What remains has found a way to exist without strain. This perspective removes any sense of repetition. Each stable outline is a solution reached independently, under different conditions at different times. The similarity lies in the problem being solved, not in imitation. Matter everywhere faces the same challenge: how to remain assembled without tearing itself apart. The solutions that succeed share recognizable traits because the constraints are universal. Once those solutions are reached, time no longer presses urgently. Change slows. The system enters a phase where evolution becomes refinement rather than reconstruction. Details shift, the whole remains. That enduring wholeness is what gives large bodies their quiet presence. They do not demand attention, they simply continue. Their forms speak of forces that have finished negotiating and found common ground. Within those forms, motion persists, stories unfold, and variation deepens, all supported by an arrangement that no longer needs to argue with the conditions of its existence. Calm at the largest scales emerges not because activity disappears, but because motion finds pathways that no longer compete. Heat does not pile up in one place. Material does not strain against rigid boundaries. Instead, movement threads its way through the interior in slow circuits, exchanging energy gradually, smoothing differences before they sharpen. What might look like stillness from the outside is, inside, a choreography that has learned how not to trip over itself. This internal choreography depends on shared participation. No single region carries the burden alone. When pressure builds somewhere, it is felt everywhere. When material shifts, the response is distributed. The body behaves less like an assembly of components and more like a single conversation happening at many depths at once. That shared response is what prevents fracture and preserves coherence over immense spans of time. Flexibility plays a quiet role here. Strength alone is not enough to last. Materials that refuse to yield concentrate stress until they fail. Materials that yield just slightly allow stress to diffuse. Over long durations, even the most rigid substances reveal a slow willingness to move. This subtle compliance is not weakness. It is what keeps the whole intact. Because of this, endurance favors arrangements that allow gradual adjustment. Shapes that permit redistribution do not need constant correction. They adapt continuously, without drawing attention to the process. The adjustment is so slow and widespread that no single moment feels decisive. Change becomes background rather than event. This background change explains why the oldest objects often appear the most composed. Their early histories may have been violent, filled with collisions and upheaval, yet what remains is a form that has absorbed all of that and settled. The violence mattered, but it did not get the final word. The final word belonged to balance. Balance, in this context, does not mean equality everywhere. It means compatibility. Different regions can behave differently as long as their behaviors do not interfere destructively. Heat can rise while material sinks. Motion can swirl while structure holds. The overall arrangement accommodates these differences without amplifying them. Such accommodation creates a natural separation of roles. The deep interior manages weight and pressure. The outer layers express variation. The surface records encounters. Each layer participates in maintaining the whole, but none dominates it. This division allows complexity to accumulate without threatening integrity. Over time, this integrity becomes self-reinforcing. Once a body has learned how to distribute strain efficiently, disturbances are handled with increasing ease. The system does not become immune to change. It becomes skilled at integrating it. Each adjustment leaves the system slightly better prepared for the next. This skill is visible in how long-lived objects respond to repeated influence. Tidal interactions, for instance, may stretch and relax a body rhythmically for billions of years. Rather than tearing it apart, these cycles often lead to internal heating, gradual reshaping, and eventual synchronization. What began as stress becomes a source of internal motion that the body incorporates. In this way, repeated influence does not necessarily weaken a system. When properly distributed, it can deepen internal dynamics without destabilizing the whole. The form remains recognizable even as the interior becomes more complex. That recognizability is crucial. It allows observers to identify states at a glance. A smooth outline suggests long-term accommodation. An irregular one hints at youth, rigidity, or insufficient mass. Without knowing the details, one can infer the stage of evolution simply by looking. This inference is not aesthetic intuition. It is grounded in mechanics. The outer form reflects how thoroughly internal processes have had time to act. It compresses history into geometry. That compression is reliable because the underlying rules do not change. Across different environments, the same compression occurs. Whether dealing with rock, ice, gas, or plasma, the logic holds. Materials differ in how quickly they respond, but not in what response ultimately looks like once complete. Time bridges those differences. Because time is so generous, the universe rarely rushes outcomes. It allows matter to explore possibilities until only those that can coexist remain. What cannot share space peacefully is removed. What can stays. The result is not uniformity, but compatibility. Compatibility allows stories to continue. Worlds that hold together can host weather, chemistry, and evolution. Stars that maintain coherence can shine steadily for billions of years. Larger structures can persist long enough to shape the environment around them. Stability is not an end state. It is a condition that makes continuation possible. Seen this way, the prevalence of settled forms is not repetition. It is the visible record of survival. Each enduring outline marks a solution that worked under its own circumstances. Similar constraints lead to similar solutions, but each solution was reached independently. The universe is not copying itself. It is responding consistently. When faced with the same problem again and again, it finds familiar answers because those answers are effective. Within those answers, variety thrives. Interiors differ. Histories diverge. Details accumulate. The shared geometry does not erase difference. It protects it. That protection is quiet. It does not announce itself. It simply holds. While surfaces change and energies flow, the underlying arrangement remains composed, offering a stable stage on which time can continue its work without unraveling what has already been built. Longevity reshapes priorities. Over immense spans, the question is no longer how something forms, but how it manages to remain assembled while everything around it keeps moving. The answer lies not in forcefulness, but in accommodation. Systems that endure learn how to absorb influence without amplifying it. They diffuse stress before it sharpens, allowing change to pass through rather than accumulate. Inside such bodies, differences in temperature, density, and motion coexist without rivalry. Warm material drifts upward while cooler regions accept it. Slow circulation replaces abrupt transfer. These motions are not visible from the outside, yet they define the internal character. What looks serene is supported by constant, measured exchange. The absence of sharp boundaries is key here. Where transitions are gradual, nothing catches or concentrates strain. Energy moves smoothly along gradients instead of piling up at edges. Over time, this smoothness becomes self-sustaining. Each redistribution reduces the likelihood of the next imbalance becoming severe. Because of this, large bodies behave predictably even when subjected to long-term influence. Cycles repeat. Responses settle into patterns. Irregularities dampen rather than grow. The system learns how to respond in ways that preserve its coherence. This learning is not conscious, of course. It is the cumulative result of countless adjustments layered over time. Each small correction leaves the structure slightly better aligned with the forces acting upon it. Over millions or billions of years, these incremental changes add up to remarkable resilience. Resilience does not imply rigidity. On the contrary, it depends on the ability to shift subtly without losing identity. A rigid system fractures when stressed. A flexible one reshapes just enough to accommodate the load. At planetary scales, that reshaping is spread across enormous volumes, making it almost imperceptible moment to moment. Such imperceptibility is deceptive. Though slow, the process is relentless. Given enough duration, even the most stubborn configurations yield. What cannot adjust is eventually reduced or removed. What remains has found a way to distribute influence evenly enough to persist. This persistence explains why mature systems often appear understated. Their drama is internal and slow. Their outlines do not shout. They simply hold. That quiet holding allows secondary processes to flourish. Chemistry proceeds. surfaces evolve. Atmospheres interact with light and radiation. None of this threatens the whole because the underlying arrangement absorbs the stress. The distinction between surface expression and structural integrity becomes especially important here. Surfaces record interaction. They are shaped by encounters, exposure, and time. The deeper form records resolution. It tells us which influences mattered most and which were ultimately integrated. Because of this, two bodies can share similar outlines and yet differ profoundly in experience. One may be geologically active, another inert. One may host oceans, another ice. The shared geometry does not homogenize them. It simply provides a stable framework within which difference can persist. That framework also limits how difference can grow. Extremes that would destabilize the whole are dampened. Processes that fit within the constraints continue. Those that do not are curtailed. In this way, the form acts like a governor, allowing motion without runaway behavior. Over long durations, this governing effect becomes the dominant influence on survival. Systems that cannot regulate internal extremes dissolve or fragment. Systems that can endure. The universe does not select for excitement. It selects for arrangements that remain intact. This selection is impersonal and unhurried. It does not act through competition, but through attrition. Configurations that demand constant correction fade. Those that require little intervention persist. Over time, the landscape fills with the latter. What we observe today is the outcome of that quiet filtering. Rounded, settled forms are common not because alternatives were impossible, but because alternatives asked too much of themselves. They concentrated stress, amplified imbalance, or depended on conditions that could not be sustained. The enduring forms are modest in their demands. They distribute influence widely. They allow time to work without resistance. Their outlines reflect this modesty. Nothing is exaggerated. Nothing insists on being different for long. This does not make the universe static. On the contrary, it allows change to proceed without erasure. Systems that hold together can accumulate complexity layer by layer. Each layer rests on a structure that does not need to be rebuilt. As time continues, this accumulation deepens. Histories become richer. Interactions multiply. Yet the basic arrangement remains recognizable. The form becomes a constant reference against which everything else can evolve. That constancy is what gives large bodies their sense of presence. They feel established, not because they are finished, but because they no longer need to renegotiate their existence with every influence they encounter. They have found a way to coexist with the conditions around them. Within that coexistence, motion persists, energy flows, and variation thrives. The calm outline does not suppress these processes. It shelters them. It allows a time to stretch forward without unraveling what has already formed. In this way, the universe builds continuity not through stasis, but through structures that can host change indefinitely. Forms that hold without effort make long stories possible. They do not hurry toward an end. They simply continue, providing a stable ground on which time can keep unfolding. Duration changes the character of influence. What begins as pressure becomes guidance. What once felt like insistence softens into expectation. Over enough time, matter no longer reacts sharply. It anticipates. It settles into patterns that require little correction because they already account for everything acting upon them. Within large bodies, this anticipation shows up as predictability. Internal motion follows established paths. Heat escapes where it can do so gradually. Material migrates along routes that have been carved not by design, but by repeated use. These routes are not channels or tunnels, but tendencies, preferred ways for energy and mass to move without resistance. Such tendencies do not need to be maintained. They persist because nothing opposes them strongly enough to erase them. When opposition arises, it is absorbed and diffused. The system responds as a whole, redistributing influence until the disturbance loses definition. This whole-body response is what distinguishes enduring forms from temporary assemblies. In a loosely connected structure, influence remains local. In a unified one, influence spreads. That spreading prevents escalation. A push in one place becomes a mild adjustment everywhere. Over immense spans, this behavior transforms how change unfolds. Instead of abrupt transitions, there are long gradients. Instead of fractures, there are slow bends. Instead of collapse, there is reorganization. The pace is slow enough that no single moment defines the outcome. Because of this, mature systems rarely surprise. Their responses are measured. Their evolution follows the trajectories that can be anticipated once the underlying arrangement is understood. This is not because they are simple, but because they have integrated complexity into a stable framework. That framework acts like a memory. It remembers which configurations worked and which did not in a conscious sense, but through persistence. Arrangements that failed no longer exist. What remains carries forward the record of what endured. This record is encoded physically, in density distributions, in rotational profiles, in subtle distortions that never quite disappear. These features tell a story of adaptation rather than struggle. They show how influence was accommodated rather than resisted. Accommodation is a powerful concept here. Resistance concentrates stress. Accommodation spreads it. Over long durations, spreading always wins. Systems that spread influence survive. Those that concentrate it do not. This principle applies regardless of scale. Whether considering a world, a star, or a vast collection of matter, the same logic holds. When influence is allowed to distribute evenly, coherence follows. When it is trapped, instability grows. Because of this, the universe gradually fills with arrangements that feel composed. Their presence is understated. They do not draw attention through extremity. They simply remain, quietly continuing while more dramatic configurations fade. That quiet continuation is what allows time to layer complexity rather than reset it. Processes can build upon one another instead of starting over. Chemistry can proceed. Structure can differentiate. History can accumulate. Without a stable form, none of this would last. Constant reconfiguration would erase progress. Stability, therefore, is not stagnation. It is the condition that allows evolution to have memory. Memory, in physical systems, is persistence of pattern. When a pattern lasts, future processes can rely on it. They can adapt to it. They can elaborate upon it. When patterns vanish quickly, nothing builds. This is why enduring forms act as anchors. They give other processes something to work against, something to reference. Their calm presence is not passive. It is generative. It enables everything else. Seen from this angle, the smooth outlines scattered throughout space are not repetitive artifacts. They are infrastructure. They provide the groundwork on which diversity unfolds. Within these frameworks, variation flourishes. Differences in composition, temperature, motion, and interaction produce endlessly different outcomes. The shared structure does not limit these differences. it contains them. Containment here is not restriction, it is support. It prevents runaway behavior while allowing internal freedom. It keeps extremes from tearing the whole apart while leaving room for expression. Over long durations, this balance proves decisive. Systems that achieve it remain available to time. Systems that do not are lost to fragmentation or dispersion. The universe keeps what can hold itself together without constant effort. This retention is impartial. It does not favor beauty or complexity. It favors coherence. What remains coherent persists. What does not disappears. As a result, what fills the cosmos is not what was most violent or most dramatic, but what learned how to exist without straining against its own structure. These enduring forms are the quiet survivors of immense histories. They do not announce that survival. They do not advertise stability. They simply continue, offering a steady foundation upon which motion, change, and detail can keep unfolding, layer by layer, without undoing what came before. Time has a way of changing what matters. At first, formation dominates the story. Collisions, accumulation, rapid change. But once a body has gathered enough substance to act as a whole, the emphasis shifts. Survival becomes less about resisting individual events and more about maintaining internal agreement. The interior learns how to pass influence along gently, how to share weight, how to let differences dissolve before they sharpen. Over long durations, this shared response becomes so ingrained that it feels almost like stillness, even though nothing has stopped moving. Heat continues to wander outward. Mass continues to adjust minutely. Motion continues to trace familiar routes, yet none of it threatens the overall coherence. What looks like calm is really efficiency perfected over time. In such bodies, extremes rarely gain traction. A rise in pressure here is answered by a subtle shift there. A change in motion is absorbed across immense volume. The response is collective rather than isolated, and that collectiveness prevents escalation. Instead of cracking or warping, the structure leans slightly, redistributes, and settles again. This behavior explains why large, mature objects rarely surprise once their basic properties are known. Their responses are not dramatic, because drama requires imbalance, and imbalance has already been spent. Early turbulence has been integrated into a framework that no longer amplifies it. The outline we see is the visible consequence of this integration, a geometry that no longer carries unresolved tension. That geometry is conservative, slow to change, and deeply informative. It tells us that the body has had enough time and internal freedom to reconcile the influences acting upon it. This reconciliation does not erase history, it compresses it. The countless adjustments that led to stability are no longer visible individually, but their cumulative effect remains written in curvature. Over immense spans, curvature becomes a kind of shorthand for endurance. It signals that a system has learned how to exist without constant correction. Inside such a system, variety can flourish safely. Chemical reactions proceed. Internal circulation persists. Surfaces record encounters. None of these processes destabilize the whole because the deeper arrangement spreads their influence too widely for any single effect to dominate. This spreading is the quiet secret behind longevity. Stress that is shared cannot concentrate. Energy that disperses cannot explode. Motion that loops cannot tear outward. The system becomes tolerant, not fragile. That tolerance allows a time to keep layering detail instead of resetting it. Without such tolerance, history would be brief. With it, history can become deep. Over billions of years, this depth accumulates quietly. What began as chaos resolves into coherence not because order was imposed, but because only coherent arrangements persist. Others dissolve, fragment, or remain too small to matter to themselves. The universe does not need to select intentionally. Duration does the sorting. What can hold together remains available to time. What cannot fades from relevance. This is why so many enduring bodies share familiar silhouettes, even though their stories differ profoundly. Similar constraints yield similar solutions, not through copying, but through necessity. Each solution is arrived at independently, under different conditions, yet the outcome resembles others because the problem being solved is the same. How to remain assembled without strain. How to allow motion without fracture. How to accommodate influence without amplifying it. The answers that work look alike because they must. Within those answers, however, there is room for endless difference. Interiors vary, histories diverge, interactions produce unique outcomes. The shared outline does not erase individuality. It protects it. It provides a stable reference against which change can continue meaningfully. In this way, enduring forms are not repetitive decorations scattered across space. They are infrastructure. They make long stories possible. They allow complexity to persist long enough to matter. Their quiet presence is not an absence of activity, but the condition that allows activity to continue without undoing itself. What remains visible, after everything unnecessary has been shed, is not drama, but agreement. Matter agreeing with influence. Motion agreeing with constraint. Change agreeing with continuity. The resulting forms do not demand attention. They do not insist on explanation. They simply persist, holding together without effort, offering a steady foundation on which time can continue to move, layer after layer, without erasing what has already come to be. What ultimately emerges from this long settling is a quiet relationship between matter and duration, one where persistence reshapes behavior more thoroughly than force ever could. As time stretches, systems stop reacting to individual moments and begin responding to patterns instead. Influence is no longer experienced as a series of events, but as a continuous background, something always present, and therefore accounted for. Under these conditions, matter does not brace itself. It arranges itself. Weight is no longer something to fight against, but something to distribute, to let pass through rather than resist. Regions that once stood out gradually lose distinction as their excess is shared away. Regions that once lagged behind quietly fill. The overall presence becomes less about holding position and more about maintaining agreement. Inside such bodies, motion acquires a rhythm that feels inevitable rather than imposed. Circulation repeats not because it must, but because no alternative offers less resistance. Energy follows paths that have been worn smooth by repetition, not carved deliberately, but revealed by use. These paths do not compete with one another. They coexist, overlapping without interference, each one carrying part of the system's ongoing adjustment. Over immense durations, this coexistence becomes self-sustaining. The structure no longer needs to discover new ways to respond. It has already settled into patterns that work. That settlement does not freeze development. It stabilizes the framework within which development continues. Surfaces may transform. Layers may differentiate. Internal motion may evolve, yet the underlying arrangement remains composed enough to host all of it. This is why the most enduring forms feel less like constructions and more like conditions. They are not actively maintained. They simply no longer require correction. Nothing inside them is pushing hard enough to demand change. Nothing outside them is able to impose it quickly. The result is not rigidity, but patience made visible. Over time, patience outperforms intensity. Violent rearrangements exhaust themselves. Subtle adjustments accumulate. What survives is not what acted most strongly, but what aligned most thoroughly with the influences that never stopped acting. This alignment leaves a distinct impression. It shows up as smooth transitions rather than abrupt edges, as coherence rather than tension, as an absence of features that would require constant explanation. The form stops calling attention to itself because it no longer contains unresolved conflict. In that absence, other stories gain room to unfold. Chemical complexity deepens. Internal differentiation increases. Interactions with surroundings become richer. None of this threatens the whole because the whole has already learned how to carry variation without magnifying it. This capacity to carry difference without strain is what distinguishes long-lived systems from temporary ones. Temporary assemblies are defined by what they resist. Enduring ones are defined by what they allow. They allow motion without fracture, change without collapse, diversity without disintegration. Their outlines are the quiet consequence of that allowance. They do not represent perfection. They represent compatibility. Across the universe, wherever matter has been given enough opportunity to adjust itself fully, compatibility becomes visible. The resulting forms are not copies of one another, but answers to the same question arrived at independently. How to remain assembled while everything continues to move. How to exist without demanding constant intervention. How to let time pass without being undone by it. The answers that succeed look familiar because the constraints are universal. Yet, within those familiar answers, there is room for endless distinction. Each enduring body carries its own internal tempo, its own layered history, its own evolving character. The shared geometry does not erase those differences. It shelters them. It provides a stable ground on which time can continue to write without having to start over. And so the universe gradually fills not with the loudest outcomes, but with the quietest successes. Forms that do not insist, do not strain, do not resist endlessly, but simply hold together, allowing motion, change, and complexity to deepen within them as time continues forward, unhurried and uninterrupted. What length really allows is room for the idea to breathe without being rushed toward a conclusion. So, instead of trying to arrive anywhere, the focus can remain on how these systems quietly keep themselves intact while everything else keeps happening. Consider how scale alters behavior in ways that are not obvious at first glance. A small object can afford to be stubborn. Its internal stresses remain local. One side can differ greatly from another without consequence. But as size increases, stubbornness becomes costly. Differences stop being isolated and begin to echo throughout the whole. What once could be ignored must now be resolved. This is where the character of large bodies truly changes. They stop behaving like collections of pieces and begin behaving like unified presences, where every region participates, however slightly, in maintaining coherence. This participation does not require awareness or control. It emerges automatically because influence can no longer remain confined. Weight, pressure, and motion spread until nothing is exempt. Over time, This spreading produces a body that feels internally consistent, not because it is uniform, but because differences have learned how to coexist without conflict. That coexistence is the foundation of endurance. Without it, systems tear themselves apart under their own imbalances. With it, they persist quietly, even gracefully, through conditions that would destroy smaller or more rigid structures. Inside such bodies, change becomes incremental rather than abrupt. Adjustments happen everywhere at once, but so slowly that they appear invisible. A shift here is answered by a shift there, not as a reaction, but as a continuation of an ongoing redistribution that never truly stops. The result is a form that feels settled not because it is finished, but because nothing inside it is demanding a different arrangement strongly enough to force rapid change. This distinction matters. Settled does not mean static. It means negotiated. It means the internal conversation has reached a point where no voice is shouting. Each influence is heard, accounted for, and absorbed into the overall behavior. When that happens, the external outline becomes calm almost by accident. It is simply what remains when all major disagreements have been resolved. That outline is not imposed from the outside. It is the cumulative expression of countless internal adjustments layered over immense durations. Seen this way, curvature becomes a record of reconciliation. It tells us that whatever forces once competed inside the body have found a way to share space without escalation. This is why outlines change so slowly once they have settled. To alter them significantly would require reopening conflicts that have already been diffused across the entire system. That takes either extraordinary influence or extraordinary time. In the absence of either, the form persists. Persistence then enables something remarkable. It allows secondary processes to become primary stories. Once the basic structure is no longer in question, attention can shift to what happens within it. Chemistry can diversify. Internal circulation can develop complexity. Surfaces can record interactions with surroundings. None of these processes would last long without a stable framework. They would be erased by constant restructuring. The presence of a calm outline is what allows detail to accumulate instead of being wiped clean. Over billions of years, that accumulation becomes rich beyond easy description. Layers form. Histories overlap. Processes interact in ways that would be impossible in a constantly destabilized system. The outline remains familiar while the interior grows increasingly intricate. This separation between large-scale stability and small-scale activity is one of the most important features of enduring systems. It allows them to host complexity without being overwhelmed by it. Without such separation, motion would either freeze everything or tear everything apart. With it, motion finds channels, cycles, and patterns that fit comfortably within the larger arrangement. Those channels are not fixed conduits. They are tendencies, preferred routes where movement encounters the least resistance. Over time, these tendencies become reinforced simply because they work. Energy follows them. Material follows them. Disturbances are guided along them until they dissolve into the background. The system becomes adept at handling influence not by opposing it, but by guiding it into forms that do not threaten coherence. This adeptness is what makes mature systems feel predictable in their responses. Once the underlying arrangement is understood, their behavior follows logically. Not because they are simple, but because they have already integrated complexity into a stable framework. Early chaos has been filtered. Only compatible behaviors remain, This filtering does not require intention. It happens because incompatible arrangements cannot last. They concentrate stress. They amplify imbalance. They depend on conditions that do not persist. Over time, such arrangements disappear, leaving behind those that can accommodate ongoing influence without self-destruction. What we observe now is the residue of that long filtering process. The universe is not filled with every possible configuration. It is filled with configurations that survived. Those survivors share certain traits because the constraints they faced were similar. They had to remain assembled while influence never ceased. They had to allow motion without fracture. They had to distribute stress rather than trap it. The forms that meet these requirements often resemble one another, not through imitation, but through necessity. Similar problems yield similar solutions when the rules do not change. Within those solutions, however, there is vast room for individuality. Each body carries its own internal rhythms, its own layered history, its own balance of processes. The shared outline does not erase these differences. It safeguards them. It provides a stable reference frame that allows variation to persist long enough to matter. Without such a frame, difference would be fleeting. With it, difference can deepen. This is why the presence of many similarly shaped bodies does not signal monotony. It signals success. It tells us that certain arrangements are particularly good at hosting long stories. They are not endpoints, they are platforms. They make extended evolution possible. Consider how many processes depend on this platform. Atmospheres require containment over long periods. Internal differentiation requires time. Chemical complexity requires stability. None of these can flourish in systems that are constantly reconfiguring themselves. The calm outline is what grants permission for these slower, subtler processes to unfold. It does not direct them. It simply makes room. Over long durations, this room becomes invaluable. It allows interactions to build on one another rather than resetting repeatedly. It allows cause and effect to stretch across epochs. It allows history to have depth. Depth, in turn, produces richness. Richness produces further differentiation. All of this rests on the presence of a form that does not demand attention to itself. A form that holds without effort. That effortlessness is deceptive. It is not the absence of work, but the completion of it. The work of adjustment has already been done, spread across immense spans until nothing remains unresolved enough to force rapid change. What remains is a condition rather than an action. A body in such a condition can be influenced without being transformed, altered without being undone. It can accept energy, shed energy, interact with surroundings, and still remain recognizable. This recognizability is not cosmetic. It reflects deep internal agreement. Every region participates in maintaining the whole, even if that participation is slow and subtle. When influence arrives, it is not blocked or reflected sharply. It is absorbed, distributed, and diluted. The system responds as a single entity rather than as a set of competing parts. That unity is the true hallmark of maturity at large scales. Unity does not mean uniformity. It means coordination. Differences remain, but they are integrated. No single difference is allowed to dominate the rest. This integration is what prevents runaway behavior. Without it, small imbalances would grow unchecked. With it, they fade. The fading may take time, but the direction is consistent. Over immense durations, direction matters more than speed. Slow correction that never stops is more effective than rapid correction that cannot be sustained. This is why time itself becomes an active participant in shaping enduring forms. Time allows influence to accumulate gently rather than abruptly. It allows matter to explore possibilities and discard those that do not work. It allows negotiation rather than confrontation. The longer time is available, the more thoroughly systems can settle into arrangements that cost little to maintain. Those low-cost arrangements dominate the long-term landscape. They do not require constant input. They do not amplify disturbances. They simply persist. Persistence then becomes the defining feature of what remains observable. Many dramatic configurations may have existed briefly, but brief existence leaves little trace. What we see now are the survivors, the arrangements that aligned themselves with the unchanging rules governing influence and response. Their similarity is not a lack of imagination. It is evidence of convergence. Independent systems, subject to the same constraints, arriving at comparable solutions because those solutions work. Within that convergence, diversity thrives. No two histories are identical. No two interiors behave in exactly the same way. The shared form is a common language, not a common story. It allows systems to be understood in relation to one another while remaining distinct. This balance between familiarity and difference is one of the most striking features of the cosmos. It allows comprehension without uniformity. It allows prediction without erasing surprise. The calm outline becomes a background against which complexity can stand out rather than overwhelm. Without such a background, everything would compete for attention. With it, patterns emerge. Meaning accumulates. Over long durations, this accumulation leads to structures that feel established, not because they are finished, but because they no longer need to renegotiate their existence with every passing influence. They have found a way to coexist with the conditions around them. That coexistence is not passive. It is active balance maintained through continuous, subtle adjustment. But because that adjustment is distributed and slow, it feels effortless. The form holds. Change continues within it. Time moves on without erasing what came before. This is the quiet achievement written into the shapes of enduring bodies. Not perfection, not finality. Simply the ability to remain whole while everything else continues to move. Once a system reaches this state of internal agreement, very little needs to be added for it to persist. The most turbulent chapter has already closed. What follows is not inactivity, but a quieter kind of continuity, where influence arrives and is absorbed without demanding reinvention. External effects still occur: radiation, impacts, subtle pulls from nearby bodies, but they no longer strike something unprepared. They meet an arrangement that has margin built into it, a structure that knows how to distribute change rather than concentrate it. This is what separates fragile assemblies from seasoned ones. Fragile systems react sharply because they cannot afford not to. Seasoned systems respond gently because they have room. That room is created by shared support. Weight is carried collectively. Pressure is spread rather than localized. No single region bears the burden alone. This collective support allows surfaces to remain intact, motion to continue internally, and history to accumulate rather than be erased. Over long durations, this accumulation gives depth to the system. Earlier adjustments remain relevant, supporting later ones instead of being overwritten. The outer form becomes a quiet assurance that nothing inside is straining to escape or collapse. That assurance matters. It stabilizes relationships with the surroundings. Orbits remain reliable. Interactions unfold gradually rather than catastrophically. Larger structures can exist because their components do not constantly threaten to undo themselves. Stability at one level enables complexity at another. Without a dependable background, finer patterns would be overwhelmed. With it, variation has space to grow. This is how long stories become possible, not illustrating finality, but continuity, not signaling perfection, but compatibility. The most enduring forms are not remarkable because they are finished, but because they no longer need to renegotiate their existence with every passing influence. They hold quietly, allowing time to build instead of erase, and in doing so, they give duration something solid to work with.